Hello world, welcome back to my YouTube channel. Today we'll be working on the climbing stairs problem on LeetCode. So to explain it, I'm actually going to draw us a picture because it's easier to understand than this explanation. So the problem gives us a staircase that takes some number of steps to reach the top. In this case, I'm using a staircase of height 4, so it takes 4 steps to reach the top. And we can climb that staircase in a couple of different ways. We can climb it one step at a time, or we could climb it 2 steps at a time, or we can climb it in some mixture of the way. So like we can do like 1 step, and then 2 steps, and then another 1 step again. And our goal is to actually count the number of different ways we can climb the staircase to get to the top. And if we try to think about the problem with this image in mind, it can get very confusing. So let's draw it in a different way to think about it more programmatically. So a better way to think about the problem is instead of climbing up the staircase, you ask yourself, how do you climb down the staircase? Going back to our example, if we were starting on a staircase of 4 steps, we can either go down 1 step or go down 2 steps. And if you go down 1, we'll be on the 3rd step. If you go down 2 steps, we'll be on the 2nd step. On the 2nd step, again, we have 2 options. We can either go down 2 steps and be at the bottom of the staircase where we began, or we can go down 1 step and then 1 step more to be at the bottom of the staircase. And you'll notice that eventually all the ends of this tree sort of terminate at 0. If we count the number of zeros we actually have the unique number of ways we can climb the staircase, right? So how can we represent that programmatically? And the answer is actually recursion. So to code this recursively, we need to set up a base case first. We know that if we are on the first step in the staircase, then there's only one way to get there, by taking 1 step. If we are on the 2nd step of the staircase, we know there's only 2 ways to get there, right? We can either take it 1 step at a time, or we can take it the 2 steps all at once. Finally, if we're at neither of those, then we know it's just how we would get there if we did 1 step or within 2 steps. So we can just return the recursion of this function by just saying take the current amount and see how many steps it would take to get to 1 step below it. And add that to the number of ways it would take to get to 2 steps below it, right? And if we run that, it should work. Nice. However, if we submit it, it won't actually be accepted by LeetCode. As you can see, we exceed the time limit because our solution is too slow. So let's take a step back and think about what we can do to optimize it. If we go back to the tree we drew earlier to sort of map out the first example of the problem, we'll notice something interesting. We'll see that we're actually repeating work in certain parts, right? This part of the tree looks the same effectively as this part of the tree, right? And even like this part of the tree looks the same as this part, which looks the same as this part. So what this indicates to us is that our algorithm is doing duplicate work. Like we're doing the same computations multiple times. And we need to figure out how to avoid doing that. Thankfully, there is a way to do that with something called dynamic programming. Dynamic programming is just a fancy way of saying, remember your previous calculations and use them in future ones. So let's try that in our algorithm next. So let's get rid of the old code we wrote earlier. And let's think about how to store it in a way that, store the computations in a way that we can remember them later instead of recalculating them each time. Let's create a list of numbers, right, that we're going to call memo. In the dynamic programming world, we call it memoization, but I like to think of it as just the word memory because we're trying to remember what we did before, right? And we'll have the index be what n represents, and we'll just add some values for it, right? So if n is equal to 0, there's no way to get to 0, so we'll just say 0 steps. If n is equal to 1, we'll say there's only one way to get to one step, which is to take one step. If n is equal to 2, then there's only two ways to get to the second step, because we do it one step at a time or two steps at a time. And what we can do now is use these values and calculate whatever n is by just filling up our memo list with more values, and then use the values inside it already to calculate new values faster. So what we'll say is that while we don't have the value we need inside memo, we're going to keep adding values to it. So we'll say that the current size of memo is going to be size is equal to memo.size. And then from there, we'll just add a new value to memo, which is going to be equal to how we get to the current height of memo, which is going to be the value of the step before it, minus one step, plus the value of the step two steps behind it. So current size minus 2, right? And this will keep going until eventually our memo array actually has values for n, right? Once we actually have the number we need, we can just fetch that value from the array. And this will work because instead of recalculating the same values every time, we're just looking back inside the two previous values in the array to figure out what we did earlier instead of recalculating it from scratch. So let's submit this and see if LeetCode likes it better than the last solution we gave. And it worked. So as you can see, we were able to solve our optimization problem. If you enjoyed this and would like to see more like it, please comment and subscribe below. Thanks.